term Pythagorean triples is just asking if this can make up a triangle with a right angle, or if it would follow the Pythagorean theorem. So do the following set here of numbers, 12, 5, and 13. Could that make up a Pythagorean theorem? Well, C, remember that C is the hypotenuse, always has to be the largest number, and then the A and B are the interchangeable smaller numbers, so it doesn't matter which one's which. So 13 is the C, so I'm going to put 12 in for A, 5 in for B, and then 13 in for C. So we're going to have 12 squared plus 5 squared. Does that equal 13 squared? That is all we need to determine. So 12 squared, 12 times 12 is 144. 5 squared, 5 times 5 is 25. And 13 squared is 13 times 13, which is 169. 144 plus 25 is 169. So this will be a match. So this one would be yes, it does. And the next one is 36, 16, and 40. So again, the largest one, 40, is the C squared, so it has to go there. So we're going to do 36 squared plus 16 squared. And again, you could do 16 squared plus 36 squared, but it does need to equal the largest number squared, which is 40 squared. So is this a true statement? Definitely want to get out your calculator for this. So 36 times 36 is 1296. 16 squared, 16 times 16 is 256. And 40 squared, 40 times 40 is 1600. So we say, hey, it does 1296 plus 256. Does that equal 1600? And that equals 1552. And that, of course, does not equal 1600. So this should be no, it doesn't. Have to get the classic frowny face for that one. So this middle one here, not a Pythagorean triple. The last one is for the pair of numbers. Find a third whole number, that means a positive integer, such that the three numbers form a Pythagorean triple. So if we said, hey, this has got to be, there's two ways to kind of guess at this. Let's say that this was C, and we're trying to figure out what if the smaller number is less than 42. So we would say, okay, let's say with A squared plus 40 squared equals 42 squared. We already know from the previous problem that 40 squared is 1600, so I'll put that in there. And 42 squared, 42 times 42, is 1764. And we're going to get rid of the stuff that's on the same side of the letter, but not touching it. That's the 1600. So the opposite of adding 1600 is to subtract 1600. So that would give us A squared equals 164. And then we take the square root of 164, which just gives us 12.8-ish, about 12.8. And that won't work because we want a whole number. So that won't work. So we got to do the other way then. So the 42, the 40 and the 42 will be the A and B. So now we have 40 squared plus 42 squared. And that needs to equal the larger number here squared. And if this doesn't work, then it wouldn't exist. So it would be possible to have numbers that just don't make a Pythagorean triple if the third number has to be a whole number. So 40 squared is 1600. We already know that. 42 squared is 1764. We already knew that from over here. And that's going to equal C squared. 1600 plus 1764 is 3364. And again, we're going to take the square root now to see what happens. Hopefully we do get an integer this time. So the square root of 3364 is 58. So that's good news that we do have an answer for it. Because otherwise we wouldn't have an answer, which is possible. So C is 58. If you have any kind of questions, please ask your math teacher.